So dear students, welcome to Fluid Mechanics class. So from today's class onwards, we will discuss Unit 2. So Unit 2, there are two chapters. First one is Fluid Kinematics and Fluid Dynamics. So this is the syllabus. So first chapter is Fluid Kinematics and the second chapter is Fluid Dynamics. So in this fluid kinematics, we already know about fluid kinematics. In introduction class, we seen what is in by fluid kinematics and what is in by fluid dynamics. Okay. So in this, as per your syllabus, classification of fluid flow. Okay, there are different types of classification is there. And then streamline, path line, straight line, and stream tube. Stream function, velocity potential function, and 1, 2, and 3 dimensional continuity equation in Cartesian coordinate. So these are all the syllabus. So first we will see the introduction about fluid kinematics. So what is meant by kinematics? So we know about statics. In first unit we discussed about statics. What is meant by statics? Fluid statics means fluid at rest. Okay, there is no external forces acting on the fluid. But in fluid kinematics, which deals the motion of the particles, that means motion of the fluid particles without considering the force and the energies causing the motion. Okay, definitely if your fluid is moving means definitely some other external forces will act. Okay, so but in fluid kinematics, we will discuss only the behavior of the fluid motion. We don't bother of the force causing the motion. Okay. So the velocity at any point in a flow field at any time is studied in this branch of fluid mechanics. Once velocity is known, then the pressure distribution and hence forces acting on the fluid can be determined. Okay. So in this chapter, the methods of determining velocity and acceleration will be discussed. Okay. So whenever fluid is moving means there are two important parameters we can calculate. One is velocity. From the velocity, we can calculate discharge. Okay. How much discharge the fluid is flowing. So these are all the salient points of the fluid kinematics. Next, types of fluid flow. Okay, types or classification of fluid flow. So there are different types of fluid flow is there. Okay, we will see in detail one by one. So first one is steady and unsteady flow. Second, uniform, non-uniform flow. Third, laminar and turbulent flow. Fourth, compressible and incompressible flow. Fifth, rotational and irrotational flow. And the last sixth one, 1, 2, and 3 dimensional flow. So let us see one by one in detail. So what is meant by steady and unsteady flow? Okay. So first we will see steady flow. Okay. Now the name itself having answer. Okay. That means the flow will be steady. Okay. The fluid characteristics like velocity, pressure, density, etc. at a point do not change with time. Okay. So, for example, flow of a fluid through a pipe at a constant rate. Okay. Constant rate means constant discharge. Okay. So here velocity, pressure, density will not vary from the starting point to ending point. That means discharge point. Okay. So unsteady flow. What do you mean by unsteady flow? Unsteady flow is the type of flow in which velocity, pressure, or density at a point changes with respect to time. Okay. So steady flow means velocity, pressure, density will not change. Okay. But unsteady flow, it quite opposite. It will change with respect to time. Example, flow of water from a compressor pump, where the flow rate or flow velocity fluctuates with respect to time. Okay, suppose in borewell, okay, in borewell using compressor motor, you can see the flow is not an steady flow. It will change with respect to time. That is the best example for unsteady flow. Now you can see here a pipe discharge a same quantity of water. So this is the best example for steady flow. Now you can see the unsteady flow. So this is the waves, tidal waves, okay, generated in the near the seashore. Okay, so here time discharge is varying with respect to time. You can see here this portion discharge is more, but this portion and this portion discharge is very less. Okay, compared to this portion. Okay, so this is unsteady flow. This is the basic difference between steady and unsteady flow. Okay, next, uniform and non-uniform flow. So here also we having answer from the question. Here the velocity at any given time does not change with respect to space. That means that is length of the direction of the flow. Okay, here velocity will not change with respect to space. Space means throughout the length of the section. So example, flow through a long straight pipe of uniform diameter. If diameter is uniform means velocity will not change. Okay, velocity is uniform. Non-uniform flow. In non-uniform flow, velocity at any section time changes with respect to space. Okay, any given time changes with respect to space. Here velocity is continuously changing with respect to time. Okay, so for best example, flow through a long pipe with varying cross section. Suppose take a pipe, one end having larger diameter. In the same pipe, another end having smaller diameter. So now you can observe when water is flowing means at the larger end velocity is very low, but it come to a smaller cross section, smaller diameter end, the velocity is more. So non-uniform flow is the type of flow in which the velocity at any given time changes with respect to space. This is the best example. Now you can see this is the uniform pipe, uniform diameter pipe. So the flow also uniform. The velocity is uniform throughout the cross section. But here you can see this pipe having varying diameter. So at one end the diameter is more, at other end diameter is very less. So here discharge is same for both end, but the velocity is different. Due to the larger area here, velocity is low, but here cross section, the diameter is small, so velocity is high. This is called non-uniform flow. So this type of non-uniform flow occurs a pipe having varying cross section. That means varying diameter. Next, laminar and turbulent flow. So it is defined laminar flow. First we will see the laminar flow. It is defined as the type of flow in which fluid particles moves along well-defined path. What is meant by well-defined path? Well-defined path means the fluid particles moving along a straight line. Just imagine a fluid particles, a fluid is flowing in the pipe having uniform cross section. Take a small fluid particle in the liquid. Okay. So that fluid particle is moving along well-defined path. So it will move along a straight line throughout the length of the pipe. For example, flow occurs in smooth pipes. Flow occurs in smooth pipes when the velocity of flow is low and liquid having high viscosity. This is the best example. Next, turbulent flow. In this turbulent flow, fluid particles are moving randomly in zigzag way. You know about zigzag. Okay. So fluid particles are not moving in a straight line. It will moving under zigzag way or randomly. So example, this type of flow occurs in rivers, canals, water supply pipes. So whenever the velocity is more, this type of turbulent flow occurs. From this figure, you can easily understand. So this is the diameter of the pipe. There are two pipes are there. This is the diameter of the pipe. So you can see here, there are different layers of fluid is there, different layers. So each fluid particles in that layer is moving along a well-defined path. So well-defined path means moving along a straight line. Okay. So this is the best example for laminar flow. Okay. Turbulent flow. You can see here turbulent flow. It is moving under randomly or zigzag manner. Okay. So it moving a curved path or zigzag manner. This is the best example for turbulent flow. So now you can see here, this is the sink tap. So here in that sink tap, the discharge is very less. Discharge velocity is very less. So water is moving in a well-defined path, in a straight line. So this is the laminar flow. You can see the flow of water in a uniform manner. Okay, in a uniform manner, in a straight line. Each fluid particles are moving in a straight line. But in case of, you can see this pipe. So due to the high discharge of the water, you can see each fluid particles are moving in a zigzag manner. So this is the best example for turbulent flow. If you want to laminar flow means you must reduce the velocity. Okay. If velocity is more means automatically it will change into the fluid particles moving under randomly or in a zigzag manner. So it's come to turbulent flow. Next, another important type of flow is compressible and incompressible flow. What is mean by compressible flow? It is a type of flow in which the density of the fluid changes from point. So in this compressible flow, we focus on density. Suppose a liquid is there. If you compress the liquid, so initially one density, suppose initially 800 kg per meter cube is there, initial density. After compressing, it will come into 1000 kg per meter cube. So density is changes when it compresses. So that type of flow is compressible flow. Okay, it is a type of flow in which density of the fluid changes from point, or in other words, the density is not constant. Density is not constant for the fluid. So incompressible flow, it is the type of flow in which density is constant for the fluid flow. So liquids are generally incompressible. So keep it in your mind, liquids are always incompressible while gases are compressible. So this type of compressible flow applicable for gases, not liquid. So for liquid, only incompressible flow only applicable. Okay. Now you can see in this picture, this is the compressible fluid, this is incompressible fluid. So in compressible fluid, whenever applying external force, the volume reduction occurs, as in our bulk modulus and compressibility in first unit. So due to the volume reduction, the density will get increases. So here initial density, this is the final density after compression. But you can see in incompressible fluid, you can't apply the compressive force. Or otherwise, yeah, very little amount of compression only you can apply. So here density will not change. Density is always constant for incompressible fluid. Next, rotational and irrotational flow. So it is a type of flow in which the fluid particles, while flowing along streamlines, also rotate about their own axis. So imagine one fluid particle. It is in a round shape. So it is moving along a pipe. Okay, whenever its movement, that round shaped fluid particles is rotate about an axis. Okay, so rotation occurs here. So it is called rotational flow. Irrotational flow means rotation is not occurs. Okay, so it do not rotate about their own axis. So you can see in this figure, this is a pipe. Okay, so in this pipe, so this is the pipe wall. This is the pipe wall. Okay, so in this figure, you can see this is the given path. Okay, fluid particles are moving in the given path. So this is the fluid particle. The smiling face cartoon is there now. This is the fluid particle. You can see here, this is the initial shape. Now it is rotating. Okay, you can see here it is rotating. So it will move along in a well-defined path. So rotation is occurs majorly in the boundary of the layer or pipe wall, near the pipe wall. So about somewhat distance from the pipe wall, irrotational flow is occurs. You can see here the spinning space will not change, will not rotate. Okay, always will not rotate, and it will move into a well-defined path in a straight line axis. Okay. So if rotation occurs in your fluid particles rotating, that means rotation occurs means it is called rotational flow. Rotation not occurs means it is called irrotational flow. So 1, 2 and 3 dimensional flow. So 1 dimensional flow is the type of flow in which the flow parameters such as velocity is a function of time and one space coordinate, only say x. So we have to consider only in x-axis. The variation of velocities in other two mutually perpendicular directions is assumed negligible. So here we are considering only x-axis. Okay, in the type of flow. Okay. So next, two-dimensional flow. Here we can consider both x-axis and y-axis. The flow velocity consider both x-axis and y-axis. Next, three-dimensional means the flow velocity in we must consider in three mutually perpendicular directions. Say x, y, and z. Okay, these are the 1, 2, and 3-dimensional flow. So up to this classification of the flow or types of flow is over. So next, three important major terminologies or definition is there. So streamline, streak line, path line. So what is these lines? So I will tell with an example. So now first consider streamlines. Streamline is an imaginary curve. Okay, keep it in your mind. It is not a real one. It is an imaginary curve in the flow such that the tangent at each point on the curve coincides with the direction of the velocity at that point. Okay, so now let us explain with this figure. So a fluid, consider this is a pipe. A fluid is flowing in the pipe. These are the fluid particles moving along a well-defined path. So now a round shape obstruction is there. A circular shape obstruction is there at the middle of the pipe. So what happened? The fluid particles are touches this shape, touches this solid, and it will move around the shape of the solid body. It will move around the shape. Okay. So now you can consider. So it will move along a curve. Okay. Streamline is an imaginary curve. Okay. So this is called the streamline. Okay. So the flow such that the tangent of each point. So now draw a tangent point for the curve. Okay. So you can see. So from here to here, it is a straight line. So after this point, a curvature will come. Okay. So now draw the straight line. Sorry, draw a tangent for the curve at each point. So the curve coincides with the direction of the velocity. The curve coincides with the direction of the velocity at that point. Okay, so the tangent is the velocity of the point. So here you can imagine from here to here it will come at a constant velocity. So after touching this solid body, the velocity. So here this is an abstraction. Okay, so due to an abstraction, the velocity get reduces. So how to calculate that velocity? So draw a tangent line for the imaginary curve. We can get the velocity. So this line is called streamlines. This line is called streamlines. Next, path line. It is the actual path traveled by an individual fluid particles over a period of time. So let us take a transparent pipe, say glass pipe. Okay. So allow fluid in that pipe. If that fluid is moving along a somewhat length of the glass pipe. Okay. So now you can drop a little bit of a color pigment. Okay, just add one drop. Okay, or ink. Okay, whatever may be a color pigment or ink. Okay, so now in that fluid, in the flowing fluid, along the flowing fluid, that color pigment also travel. Okay, so now observe that color pigment, the color solution, one drop solution. So how it will moving along the fluid, whether it moving straight line or whether it moving in a zigzag manner or random manner, just observe. Okay, I think you can understand. Take a glass tube filled with some liquid, a transparent liquid. Okay, yeah, oil, whatever it may be. Okay, it must be a transparent. Just add one drop in one end. Okay, not in all the place. Just add only one drop of the color pigment or color solution. Okay, so now observe the movement of that color pigment. So that movement tells the that motion of the fluid. Okay, that movement of the color solution tell the how the fluid is moving. Okay, based on that we can easily understand. So that line is called path line. The color pigment traveling line, whether it may travel straight line or it may travel curved line or it may travel in a zigzag manner, whatever it may be. Okay, so that line we can easily identify. Okay, that line is called path line. Okay, so the path line indicates the exact route. Okay, along which a fluid particles travels from its starting point to its ending point. Okay. So this is called path line. So you can see here, this is the starting point, this is the ending point. So fluid is traveling. A color pigment is adding here. So the fluid is traveling. So here, this is the start point, this is the end point. So you add color pigment here, one drop. So that color pigment moves along this line. So this is called a path line. Okay. So next, streak line. So the best example for understanding the streak line means you can already observe a smoke coming from an agarbatti or a smoke coming from a chimney, industrial chimney. What you observe? Suppose if you take one agarbatti, okay, using matchbox, you can burn the agarbatti. So after that, what you observe? A smoke will come. Okay. So now from the smoke, what you understand? So the smoke, if in that room there is no air, means the smoke will be perfectly straight line up to some height. Suppose air is there, there means the smoke will not go perfectly straight line. Somewhat undulations are it moving in a zigzag manner or curved manner. It will move in a curved manner. So what you understand from the smoke, shape of the smoke? So that is called, that line is called a streak line. So it is a line that is traced by a fluid particles passing through a fixed point in a flow fluid. So we can trace the movement of the fluid particle. We can trace the movement of the fluid particle from that line. Okay. So from that agarbatti smoke, we can easily understand the movement of the air in that room. Okay. Suppose air is passing from left to right. Left to right means the smoke also moving from left to right. Okay. So that smoke derived from that agarbatti, that line is called a streak line. So you can see here a glass tube is there. Okay. It may be a dye or smoke will be delivered. Okay. Injected fluid particle. So from here that smoke or dye is moving along this line. So if you connect all this point, that point is called the streak line. Okay. So I hope all of you understand about the difference between streamline, path line and streak line. So next, stream tube. So previously we seen streamlines. Okay. Suppose you join all the streamlines. That is called stream tube. A region of the moving fluid bounded on the all sides of the streamlines is called a tube of flow or stream tube. Okay, a region of the moving fluid bounded on the all sides by a streamlines is called a tube of flow or stream tube. Another name is tube of flow or stream tube. So you can see here these blue lines are the streamlines. Okay, so now you connect all the streamlines. Okay, so it is like a tube. It is like a tube. So that is called stream tube. So next important definition, discharge. Discharge. Okay, what is meant by discharge? So whenever we are bathing or cooking vegetables or washing cloth means we simply open the tap. Okay, so water is coming from the tap. So from that only we are collecting from bucket or kitchen vessels. Okay, so the pipe is discharged constantly. The pipe is discharged constantly of water. So now based on this, tell me what is discharge. So it is defined as the quantity of your fluid flowing per second. So for 1 second, how much water is delivered? Amount of water delivered per second is called discharge. Okay, so it is defined as the quantity of a fluid flowing per second through a section of a pipe or a channel. It is applicable for pipe as well as channel. For an incompressible fluid, the best example for incompressible fluid is water. The rate of flow or discharge. So the another name of discharge is rate of flow. The rate of flow or discharge is expressed as the volume of the fluid flowing across the section per second. For compressible fluids, the rate of flow is usually expressed as the weight of the fluid flowing across the section. Okay, keep it in remember. For incompressible fluid, it is volume of fluid flowing across the section. But for compressible fluids means gases. Okay, in gases we have to calculate weight of the fluid. There is volume here, weight. For incompressible, volume, compressible, weight. So the unit of discharge is meter cube per second. Meter cube per second. For 1 second, how much meter cube of liquid is discharged? Okay, or liters per second, So sometimes in the problem they given in meter cube per second or liters per second. So for gases, unit is kgf, kilogram force per second, or Newton per second. Okay, so because we have to calculate weight for compressible fluids. So consider a fluid flowing through a pipe. Okay, so consider a pipe. A 1 meter length pipe is there. Water is flowing in the pipe. So how to calculate the discharge? It is very simple equation. So discharge equal to area of the pipe into velocity. Area of the pipe into velocity of the pipe. So the discharge symbol is Q. And the unit is meter cube per second or liters per second. And the formula is AB. Area of the pipe multiplied by volume. Sorry, velocity. V is not volume, it is called velocity, average velocity. Area of the pipe. So we know that all the pipes are having circular cross section. Okay, so this formula again reduced into A, substitute area formula. Q is equal to pi by 4 d square. D is the diameter into velocity. So this is the formula for the rate of flow or discharge. So next, continuity equation. So this equation mainly used to calculate the discharge in a pipe in different places. So what do you mean by continuity equation? The equation based on the principle of conservation of mass is called continuity equation. Thus, for a fluid flowing through the pipe at all the cross section, the quantity of fluid per second is constant. Okay, suppose if you take this is a pipe having different cross section. So here diameter is less, here diameter is more. Okay, so due to this diameter, velocity will vary. So here velocity is more. In this cross section, suppose take this cross section 1, 1. In this cross section, velocity is more. But if you consider second section, the velocity is less. Why here velocity is less? Area will be more. If area increases, velocity decreases. If area decreases, velocity increases. So that area and velocity both are indirectly proportional, not directly proportional. So even though velocity and area different, discharge is same. Discharge is same. So in unit 1, we seen Pascal's law. So pressure is constant at any direction. Okay, as per that law. So as per same Pascal's law, here discharge is constant. Even though area and velocity is different, always whether uniform pipe or a tapered pipe or non-uniform pipe, discharge will not vary. Always you can check anywhere, discharge is constant. Okay. So now let V1, average velocity at cross section 1, rho 1 is equal to density of section 1, 1, A1 equal to area of the pipe at section 1, 1. Okay. So V1, velocity, rho 1, density, and area, A1. Okay, for section 1. So same as V2, rho 2, A2 for section 2. Okay. According to the law of conservation mass, rate of flow at section 1 is equal to rate of flow at section 2, 2. So equate both the equation, rho 1, A1, V1 equal to rho 2, A2, V2. Okay. So this is this equation applicable to the compressible as well as incompressible fluids is called continuity equation. So rho 1 A1 B1 equal to rho 2 A2 B2. This equation is called continuity equation. So this equation applicable for both compressible as well as incompressible fluids. Okay. So if you take incompressible fluid, we already seen incompressible fluid. What do you mean incompressible fluid? So in that fluid, if external pressure or external force is acting, density will not change. Density is constant. So now you can see in this equation, here rho 1 is the density, rho 2 is the density. If the same liquid is flowing, so take this water. We know that the density of water is 1000. If the same liquid is flowing, rho 1 equal to rho 2. Density is same now, meaning that, okay, whether it will take section 1 or section 2 or section 3, whatever it may be, density is same. So rho 1 is equal to rho 2. So this rho 1, rho 2 get cancelled. So what is the final equation? So this above equation is reduces into after rho 1 cancelling. So A1 B1 equal to A2 B2. So we already discussed previously, discharge is equal to A into B. Okay. So A1 B1 is the discharge at section 1. A2 B2 is the discharge at section 2. So for both the section, discharge is same. So this is the continuity equation. So this equation is very, very important. Based on this equation, from the next class, we will see problem. Okay. So after this class over, we will see next class with the problem in the continuity equation. Thank you.